For decades, serotonin has been typecast as the feel-good neurotransmitter, a bubbly brain chemical best known for influencing mood, sleep, and why you suddenly feel better after a long run or a decent bowl of pasta. But aging scientists are now tuning into a deeper, more systemic role for serotonin, specifically the receptors that respond to it. Because these receptors, it turns out, aren't just sprinkled throughout the brain. They're everywhere. In your gut, your heart, your liver, your bones, even your immune system. And increasingly, the scientific consensus is shifting toward a provocative idea. Serotonin receptors may be master regulators of whole-body aging. The most attention-grabbing of these, especially in the psychedelic renaissance, is the 5-HT2A receptor. It's the receptor responsible for the mind-expanding effects of compounds like psilocybin and LSD. But beyond the trippy visuals and spiritual epiphanies, 5-HT2A has been implicated in a surprisingly wide range of biological processes, including inflammation, mitochondrial activity, synaptic repair, and cellular plasticity. That alone would make it a tempting target for aging researchers. But 5-HT2A is just one receptor in a much bigger family. There are at least 14 known serotonin receptor subtypes, grouped into 7 families, 5-HT1 through 5-HT7, and they're distributed all over the body, like a secret biochemical Wi-Fi network. In the cardiovascular system, serotonin receptors regulate blood vessel tone and heart function. In the gut, where more than 90% of the body's serotonin is produced, they influence motility, secretion, and microbiome signaling. In the liver, they affect lipid metabolism. In the bones, they play a role in remodeling. And in the immune system, they modulate the balance between pro- and anti-inflammatory signaling. Everywhere you look, serotonin receptors are quietly tuning the body's response to damage, stress, and time. This widespread influence is what has caught the attention of neuroscientists. One emerging theory is that serotonin signaling may act as a master switch between growth mode and repair mode, two opposing cellular states that define how organisms allocate energy. In youth, serotonin-driven pathways lean toward growth, proliferation, and metabolic speed. But in aging, that same signaling may become dysregulated, pushing tissues toward fibrosis, chronic inflammation, or immune exhaustion. The idea is that by carefully modulating specific serotonin receptors, we might be able to rebalance these signals, encouraging regeneration without fueling pathology. There's already some tantalizing evidence to support this. Studies have shown that stimulating certain serotonin receptors can reduce oxidative stress, enhance mitochondrial biogenesis, and promote neurogenesis even in aged animals. Others suggest that blocking select serotonin receptors may suppress cancer cell growth or reduce fibrosis in aging organs like the liver and lungs. And in the brain, 5-HT6 antagonists have shown promise in improving cognitive function and slowing neurodegeneration. One particularly exciting area is the intersection of serotonin signaling and inflammation. Chronic low-grade inflammation, or inflammaging, is one of the core drivers of biological aging, and serotonin receptors seem to sit right at the heart of that firestorm. In immune cells, serotonin modulates cytokine release, T-cell activation, and macrophage behavior. In the gut, it helps maintain the integrity of the intestinal barrier, which is crucial for keeping microbial toxins out of circulation. In the brain, it influences microglial reactivity, one of the main culprits in neuroinflammatory decline. All of this means serotonin signaling may be a unifying thread linking mood, metabolism, immunity, and aging. Of course, this doesn't mean we're about to start handing out SSRIs to slow down aging. In fact, the relationship between serotonin levels and aging is highly nuanced. Simply flooding the body with more serotonin can backfire, especially if the wrong receptor subtypes are activated. What researchers are aiming for instead is targeted modulation, using molecules that gently nudge specific receptors in the right tissues at the right time. This is why there's so much interest in novel compounds, including non-psychoactive psychedelic analogs, that can tap into this system with surgical precision. So, are serotonin receptors the next big thing in longevity science? They might be. Not because they offer a silver bullet, but because they sit at the crossroads of so many critical aging processes: energy balance, stress adaptation, tissue repair, immune modulation, and neuroprotection. And unlike many genetic interventions that are years away from clinical use, serotonin-targeting drugs already exist. We just haven't fully appreciated their potential beyond the brain. In the coming years, don't be surprised if serotonin receptor agonists and antagonists start showing up in unexpected places, being tested not just for depression or anxiety, but for frailty, sarcopenia, cognitive decline, and even immune resilience in older adults. What started as a happiness molecule may turn out to be a cellular conductor, quietly orchestrating the pace of aging across the entire body.